Okay, good morning, everyone. My name is Philip. I am talking here on behalf of Innovators in Technology, the college's Computer Science Students Club. Today, we have the honor to host this workshop with Glauber. Glauber was a student in the past in the college, and today he is working on the industry. And he is sharing with us his knowledge. He has a lot of knowledge in C Sharp. More than 10 years of C Sharp development. Is it right, Glauber? 10 years, right? More than that.
Yeah, pretty much more than 10 years, yeah.
And he is a certified professional programmer for Unity. And that's it. Today he will share his knowledge with us. So I'm proud to call Glauber to start this workshop.
Thank you, Philip, for this introduction. And I would like also to thank all Inti members and especially Ms. Nariman Mansour for organizing this event. That's a workshop that I have been looking forward for a long time to present. And also, La Salle College has a very special place in my heart. I remember I had the opportunity to meet a lot of friends and also to meet amazing teachers over there. And for me, it's such a great pleasure and honor to discuss a little bit about those two main topics. The first, multiplayer programming, and also the Azure cloud. And speaking of which, that's gonna be the two main topics that we are gonna discuss today. For the multiplayer section, we're gonna have a couple of practices, and then with one of them, this Intbots game, we're gonna export for the web platform later on, and then we are gonna publish on the Azure cloud, and then we're gonna discuss a little bit about the benefits you can have on publishing your game on the Azure cloud. So the first question I would like to introduce you is, why should you consider introducing the multiplayer feature in your game? I came up with this list based on the most 10 played games on Steam, and as you can see, 9 of 10 implement the multiplayer feature. This is a very big deal, and also this is a trend in the market. The only exception is the Cyberpunk 2077, but I heard a couple of weeks ago that the company behind the game is considering to implement this feature later on in a DLC or as a sequel, probably. And yeah, that's something we cannot simply ignore. This is a fact, and you definitely should considering such feature in your games. For this workshop, we're gonna use this PHOTON plugin, and this is a middleware created by a company called Exit Games, and they have their infrastructure running on IBM clouds, so you don't have to worry about scaling up your game. This is a very strong and secure infrastructure. Also, they support a lot of platforms, including Unreal and Unity as well. But that's not the only two platforms, they support many more. Of course, this is a very simple way to introduce you to the multiplayer programming world, and it's actually very easy. But not just because it's easy. Because it's easy, you are going to programming like in a way you are going to spend a lot of resource. Of course, you have to be always conservative with the network traffic you are going to generate with your game. And yeah, we're gonna see more about that in our example shortly. They also have their infrastructure spread all over the world with servers in basically in all continents. And the good news is that they have also a server here in Montreal. And yeah, that's a pretty infrastructure, a very mature infrastructure they have. And if I should take if I would explain you the life cycle of this plugin in a nutshell, that's the picture I would like to show you. Of course, this is a very simple way to explain the entire round trip you are gonna have with this plugin implemented in your game. But let's see how it happens. Basically, once you have this handshake process performed by your player running your game, your player is going to join what we call a lobby. A lobby is nothing but a place where your player can create rooms or basically create rooms or list other rooms in order to meet other players. If your game is very simple, like a mobile game, for example, uh, you you probably are not going to implement this create or list rooms feature. Probably you just want to join your player with other random players, and that's actually very easy to implement. Once your player joins the room, there are basically two ways you can share informations across your players in order to sync your screen, the screen of your player, with other players. First, you have the opportunity to share the view of your player with other players. You can send or receive what we call remote procedure calls. And finally, we can also share custom properties. It's possible to create your own properties in order to spread across the network. But we will see more about that in our example. And the first thing I'm gonna do, I'm gonna open the PHOTON website, and feel free to follow me. I'm gonna open photonengine.com, and we have to sign in with an account. I'm gonna sign in with mine. Once you are signed in, you go to dashboard and then your applications. Then you click this create a new app button. For the photon type field, please select photon PAN and provide a name for your application. You can leave those other fields blank. That's okay, and hit create. Okay, so basically we already have our application registered on the platform, and notice this 20 CCU label. It means our application is capable of handling 20 simultaneous players for free. You don't have to pay a single dime for that. But if your game is going to have more players than that, you're gonna have to consider their paid plans. You can explore more that on the Photon website, but as for starters, that's very interesting. Then notice this app ID. That's going to be the identificator that we're gonna have to use in our application. The first thing I'm gonna do, we will have to copy and paste this this identificator in our application, and that's what I'm gonna do now. I'm gonna open Unity and let's create our first application for this practice. I'm gonna hit new and select a folder for your application. I'm gonna stick with this level up folder and I'm gonna call it like Photon demo. In the meantime, as this progress bar is not finished, we will have to open the asset store. So let's go there because we will need the Photon plugin on our game. So let's search for 1, 2, 3 and let's click here. And then we will have to click this open unit, but before that let's see if this process is finished. Okay, so we are good to go. Let's click here, open in Unity, and that's going to bring the package manager window. So we will have to wait a little bit, or let's hit open unit once more just to make sure. Yeah, because you have to have this PHOTON title on your screen in the title of your package manager window, and then you can click import. Click import again on the pop-up. If that's the first time you are doing this example, probably you have first to click download and then import. In the meantime, let's go back to our dashboard, our Photon dashboard, and look at that. We need this app ID. So you click on the label, you right click the entire identifier and you copy. You have to copy this value, and let's go back to Unity, because once that process is finished, you have to paste this value on the text box, and then you click on the button Setup Project, and then you can finally close this pop-up window. Okay.
Hey Glauber. So basically, Photon is the SDK we are going to use to host the game as a multiplayer game, right?
Yeah, exactly. And the assets we have just downloaded from the asset store that's gonna do the job can be found in this folder under assets and Photon. And let's collapse for now this folder. And that's right, it's going to handle the entire multiplayer infrastructure for us out of the box. Now, I would like to tweak a little bit the lighting for the environment. So for doing that, let's go to our project, our menu window, and then let's go to rendering, lighting. Select environment tab, And in the environment lighting, select in the source, instead of skybox, select color. In the ambient color, click over this gray box, which is the color, and let's configure this color with the following values for the RGB. All of them is going to hold 100. And that's pretty much it. Now, let's go back to our browser, because we are going to use a specific texture for this game. And please open the following link, bit.ly/workshop texture. And we're gonna save this texture on the project folder of our game. So I'm gonna right click, save image as, and I'm gonna go to my project folder, which is level up, PHOTON demo. Go to the assets folder, and here you can create a new folder called textures. Go to that folder and save the file. Go back to Unity and make sure your texture is under the textures folder. Okay, now let's create a game object by clicking on the menu Game Object, 3D Object, and what I'm gonna do, I'm gonna create a terrain. So select terrain, and let's place this terrain on the following coordinate. For the position X, put -500, Y -0.5, and for Z -500. Okay, so let's use our texture on our brand new terrain. And for doing that, let's go to this icon called Paint Terrain. Then click on Edit Terrain Layers, create a new layer, and search for your texture called ground, and select the texture, and then you can close the window. As you can see, the texture is now applied on the terrain. We're gonna create a couple of folders on our project window. So for doing that, make sure you right-click the assets folder, then right-click, go to create folder. We're gonna create the materials folder, then we're gonna create the folder called resource, and finally the folder called scripts. On the materials folder, right click and create a material by right click on the material folder, then go to create and select material. Let's name it as player. Now we're gonna need some custom scripts in order to give our game, our application, some intelligence to respond to certain events. And first I'm gonna create a script under scripts, select script, and then right click, go to create C# script. And that first one is gonna be called as like character movement. And let's create 3 more scripts. The next one's gonna be our player script. Then we're gonna create the UI manager script. Sometimes you have to wait a little bit Unity to compile your script. I just created under resource by mistake. I'm gonna move under scripts. And the last script is going to be our room manager. And now we're gonna, for the first time, do some code. Let's double click our character movement script. It's gonna open Visual Studio. And let's do some coding. We're gonna need basically just 2 namespace. So we're gonna use the using keyword photon dot pun namespace. Then we're gonna have to create a couple of serialized fields. If you are not so very familiar with Unity notation, the serialized field is just a decorator you can place above classes and also field members, variables, and it means, let me type serialized field and create our first serialized field. It's gonna be a private float character speed, and I'm gonna initialize with 8. And what does that mean? This serialized field means since you have this variable as private, it's not going to be visible outside the scope of the class, but since you decorated with serialized field, you can change the value of this variable under Unity editor. I'm gonna save this script and I'm gonna go back to Unity. And I'm gonna create a game object like a cube, for example. We are gonna use a cube actually. 3D object cube, and I'm gonna name it as player so you can see what the serialized field means. In the inspector for our player, go to the bottom and click add component and search for your character movement script, hit enter. And since you apply the serialized fields, you are able to see the variable here. If you comment out or remove the line and you go back to Unity, it's not going to be visible anymore. So that's the serialized field. Okay, and we will need a couple of other serialized fields. We are gonna create a float jump speed, and we are gonna initialize with 12. Another serialized field called gravity. We're gonna initialize with 20. This value is going to be used by the character controller. Character controller is a component, native component from Unity, and we're gonna hold a reference of a character controller applied for our player. We're gonna hold the reference in a variable called not in capital, character controller, and we are gonna hold the reference on the awake function. We're gonna do that later on. We're gonna need just a couple of private fields more. This one is gonna be vector3, and it's going to be used to hold the input vector. I'm gonna call it like input vec, and I'm gonna initialize right away. This is the instantiation. Okay. And finally, we will need a photon view. And we will see how it works later on as well. As I said previously, we will need to cache the reference of our character controller in the awake moment of our component. So for doing that, I'm going to create a private void awake. And finally, we can set it by calling get component character controller. This is a good practice. When you are going to use many times the component, instead of calling get component and the type of the component all the time, it's a good practice to do that just once. You cache the reference. We are just caching the reference in a variable called character controller. So we don't have to call the get component all the time. It's going to be more performant. Then, in the start method, we're gonna cache also the reference for the photon view. We can do that also on the awake method. Let's do that here. View equals get component photon view. And then on the start method, we will have some logic. And let's see what we can do here. We can call a property called isMine from the view, which is a Boolean property. And I'm gonna explain that shortly. Before that, let's just finish this line. We're gonna call the photon network class, and there is this method called inroom. And this if statement is going to evaluate two situations. If this is your player or you are not in a room, what I want to do, I want to parent the camera, the current camera of your game, in that case the main camera. Let's go back, and I would like to parent to our player. So if you move your player, I would like to camera to keep following it, our player. So let's create a method. I'm gonna use, instead of using public all over our code, I'm gonna use internal as a good practice to keep the lists visible as possible. And I'm gonna call it like attach camera. And that's going to be a very simple code. It's going to look for our main camera, and it's going to parent the camera to the game object holding our character movement script, which is going to be our player. And to do that, we set to transform. dot parent dot transform dot parent. Yeah. By doing that, you are changing the parent of the camera. And then we can call this function, this method attach camera. If it's your player, or if you are not in a room, then I want to parent the current camera to our player. Okay, so for the update method, which is gonna be called every single frame in our game, I would like to check if our player is performing some inputs in order to move our player. For doing that, I'm gonna create a private void update position by input. And again, we are going to check if the view, the current view, belongs to our player, and if our player is currently connected to the PHOTON network. So, if the view, the current view, doesn't belong to our player, because I'm using the not operator, and if the player is connected, then I'm gonna ignore the execution by returning. Otherwise, if the view belongs to our player and the player is connected, then we can keep going. Remember our input vector we created as a vector tree? Now we're gonna use this variable input vec. We're gonna apply the x property is gonna hold the return value of input dot get axis horizontal. This is a built-in function offered by Unity. And let's multiply by our character speed. And this is very simple, very straightforward, basic feature of Unity. Input get access returns for you the value the user is performing to move your character. And let's do the same for the y. Input vec dot y is going to check the vertical axis. And let's multiply by the character speed. Okay. Now, let's check if our built-in character controller is grounded, if our player is on the ground, and if our player is trying to jump by pressing the jump button by using the get button down function, passing the parameter jump. Unity is going to check this function for us, and if this condition is met, then we can set our input vec in the property y the value of our jump speed. Finally, we have to apply the gravity set in the gravity variable. We have to configure our character controller with this gravity value. By doing that, for doing that, I'm gonna set the input vec dot y is gonna be decremented by gravity multiplied by time dot delta time, which is gonna calculate the current frame rate for us. If you are running this code in a low-end CPU, the delta time is gonna ensure for us this constant. This value is going to be constant comparing to a fast CPU. That's what this time delta time is going to return for us, this calculation. Finally, we can set our character controller. We can call the move method by passing our input vec and again multiplying by time dot delta time. And that's pretty much it for this script. Now let's go back to Unity and let's configure a little bit more our player. Ensure your player is set to the position 000 on the XYZ axis, and let's apply the player material by selecting the player material under the folder materials. Let's drag and drop all the way under element 0 on the inspector window. Next, let's we already have our character movement script applied. We will have to include other components as well. Let's include the character controller script, which is a built-in component available for us, created by Unity. Next, let's include the player script, the custom script we created previously. We're gonna code this class later on. Next, let's include the PHOTON view component. It's here. And finally, we will need another PHOTON component, which is the PHOTON transform view. Okay. So we have all our scripts set on our player. There is just one thing I would like to ask you to do on the character controller. Go to skin widget and set the value to be, let me check here, 0001. I'm just checking here, because if you set to 0, yeah, configure the value to be 0, and Unity is going to correct the value just to avoid a minor issue later on. Now let's configure our camera. So click on the main camera. For the position, let's leave X with 0. For the Y, let's put 9. Z minus 15. On the rotation X, let's configure with 20. And click on the game window, the tab game, and make sure you have this, you can visualize this picture on your Unity. Okay, let's go back to scene and let's save our scene. It's a good idea. We have done a lot of work so far, and let's play and let's see what happens. I just wanted to make sure that we are already able to move our character by testing our game, by pressing play, and then by pressing the arrow keys from your keyboard. But if you are testing on your own, probably you are not able to move yet your character because we just missed a point over here because we created this method called update position by input. We actually need to call this method on the update method from the built-in update method of Unity. And also there is a typo on the on the calculation for the vertical axis. We are not supposed to use the y axis, the y property of our input vec. It's actually the z. So let's fix that. Let's save our script and let's go back to Unity in order to test our game. Let's press play and check if you are able to move your character by pressing the arrow keys from your keyboard, and try also to jump by pressing the space bar. If you are if everything is correct, you will see something like that. Now let's code our player class. So double click your player script and let's go to Visual Studio. We're gonna need a couple of namespaces. So for the first one, I'm gonna import the PHOTON pan, and also let's get rid of this namespace and let's use the unit engine .ui because we're gonna deal with some controls in order to configure the appearance of our player. Okay, we're gonna need a couple of private variables. First, we're gonna need a photon view again, and we're gonna perform the same thing like the previous class shortly. Then we're gonna need a text mesh in order to create a label above our player with the correspondent nickname, and we're gonna call it like nickname label. On the let's create a awake void awake. And if you are wondering why I am not caching the reference of those components on the start method, because we could do that actually. We could perform the same thing, holding the reference of our photon view component on the start method. It would work, but that's a personal choice of me because probably if you are familiar enough with Unity, you already know that the awake method is called by Unity before they start. And since this is a very important step, I don't want to mess up this execution. I usually like to hold my reference on the awake, and then we could play around with the start method without doing that, as you can see. Now, for the awake method, that's it. And we're gonna work with the start method later on. Let's create first a couple of methods. First, one specific for handling the name, the label of our player, and let's call it like add nickname label. And we're gonna have a couple of lines here. First, let's create on the fly a game object called nickname game object, and it's gonna be a new game object with nickname label as a parameter in order to have this name. Our nickname object, let's create, remember we have this nickname label text mesh. We're gonna configure this object now, nickname label, and we're gonna include a component by calling the nickname game object dot add component text mesh, and now we are good to go to configure other properties for this nickname label. We're gonna apply the value, and it's gonna use our view. We're gonna call the property owner, and there is a property called nickname, and it's gonna hold the value of the nickname of our player. Let's set the color nickname dot color to be gray, color dot gray. Let's set also the font style to be bold. The alignment to be center. The anchor to be middle center. The font size to be 120. Also the character size, and it's gonna have 0.065. Then we're gonna use our game object, nickname game object dot transform dot parent to be the player itself. For doing that, we just call transform. Finally, we're gonna set the position to be a specific coordinate. For doing that, we need to instantiate a new vector tree in order to control the positioning for this game object, and it's gonna hold 0 for x, 1.5 for y, and for z 0. And yeah, that's gonna be our add nickname label method, and don't forget to call this method on the start method of your script. Then we will need another another method in order to retrieve the color, and this one is going to be is gonna have way less lines comparing to the add nickname. I'm gonna create this method like retrieve initial color, and I'm gonna create a variable called color name, and it's gonna check our view object by accessing the property owner. And there is this, do you remember that previous slide? I was talking about the possibility of using custom properties. And that's exactly what we're gonna use now. This custom properties property, and we're gonna use this color name custom property, and we're gonna convert to a string. Then this line is just to retrieve the name, the string name of the color, but we want, what we really want now is to apply this color to our cube. So let's create a function responsible for doing that. It's gonna, I'm gonna call this function, it doesn't exist now, but just to avoid a mistake to forget this call here, I'm gonna create anyway. And we can use the shortcut control dot, and we can call this generate method for us. That's an interesting trick for of Visual Studio. Now, this update nickname, update color actually, has to use a decorator called pun RPC. And as I said earlier, we are able to communicate informations across other players by using what we call remote procedure calls. And basically we are telling PHOTON this update color is a kind of method that's able to be executed not just by ourselves, but also by other players. So for doing that, you have to use this decorator, and let's put some intelligence over here. First, I want to set the color. I'm gonna create a variable called color, and I'm gonna use a built-in function from Unity called try parse HTML string, and we have to pass a string, a color name, and there is a by half parameter, so we need to use the alt keyword, and we're gonna pass this color variable we just created here. We created this color variable, and then we pass as the second parameter of the try parse HTML string method of this color utility built-in class. Okay, then I'm gonna call on my own game object the get component renderer. So I am able to change the color of my player. So I use the material property, and I have under material I have the color property, then I am able to set the color property. Finally, we have to check if this player is actually our player. For doing that, we can use the view, and if it's actually our player, because we are basically over here, we are changing the color of our player, and we want to communicate this change to the other players. So if this guy over here is ours, so we have to communicate. For doing that, we use PHOTON network, the PHOTON network class, and the local player property, and we use the custom properties. Color name is gonna hold our color. This line is basically saving the color name as a custom property, but it's not broadcasting this information yet. We're gonna do that. Next, we're gonna call PHOTON network local player set custom properties PHOTON network dot local player custom properties. Yeah, this line, this entire line is actually saving the custom property, because if you just change the custom property and you don't call the set custom properties method, it's not going to be saved. So when you work with custom properties, don't forget to call the set custom properties method. Finally, now we are able to broadcast the information. For doing that, we use our view, and there is the RPC method, and then we pass as a string parameter the name of the method, in our case update color, which has the pan RPC decorator as a parameter, as a string parameter of our RPC method. And there is a couple of interesting parameters. The second parameter, RPC target, is able to handle the way we are gonna broadcast this information. Notice we have this all constant value. Actually, if we use the all, the information is gonna be broadcasted to all players, including ourselves. But in this situation, we don't want that. We just want to broadcast this information to the other players. So for that, we use the others option. And finally, we are able to pass a parameter. This line, this RPC, behind the scenes, is going to, on the other machines, for the instance of this game, for the other players, is going to call the update methods for the other players, but we have to pass the color name. And by doing that, for doing that, you have to use the third parameter in order to supply the update method color, in order to pass the color name. Let's say you had more parameters, a second, a third, a fourth parameter. If you had this situation, you could pass other parameters as well. But in our case, we just have one parameter, and that's gonna be the color name. Okay, that's the update color. I'm gonna move I'm gonna cut this code just to organize a little bit more, and I'm gonna paste this code in order to have this retrieve initial color and the add nickname label. Let's call this retrieve initial color in the start method, and also we will need a corresponding method in order to broadcast the other players if we have a nickname change for our player. Let's do that. It's gonna be a method called update nickname. It's gonna receive a nickname string, and it has to be another PHOTON RPC. Don't forget to put the decorator for this method as well, because it's gonna be another remote procedure call. Now we will use the view, and we're gonna set the nickname of our view, the owner of our view, to be a game object that's gonna hold the value of our nickname. And I'm gonna create later on a input field called nickname, and it will have a component called input field. We will create that later on the Unity editor, but for now let's finish this method. The nickname label has to be updated as well, so let's do that. And again, if it's our view, if this is our player, then view is mine. We can broadcast this information to the other players by calling view RPC we are gonna call the same method, update nickname, we're gonna send this information to the other players, and finally we pass the nickname. And that's pretty much it for this method. Yeah. Let's go back to Unity, and let's wait for the compilation to conclude. Okay. Now we really need to transform our player into a prefab. And for doing that, let's drag and drop our player game object from the hierarchy window, and let's drop into the resource folder. And this is a very important step. Why? Because when we are dealing with components with the PHOTON view, the PHOTON view component, if our game object has the PHOTON view component, and if we are going to instantiate this game object on the fly later, like we are gonna do later on, it's very important to have this prefab located on the resource folder. That's the way we're gonna work later on. Now, since we already have our prefab, let's create a game object that's gonna hold our room manager component. For doing that, I'm gonna go to the game object main menu, then I'm gonna go to create empty. And let's rename this game object to be our room manager. And then on the inspector, let's click add component and let's add our room manager script. Okay, and now we're gonna code this script. Let's double click. And we're gonna need a couple of namespaces. First, the PHOTON PAN. Then we're gonna need the PHOTON real-time. We're gonna need the PHOTON engine, the Unity engine that's there already. And finally, we need the unit engine.ui because we are gonna work with some user interface components. Okay, first let's create a method, a private method void called connect, and connect. And this entire class, this room manager, keep in mind that it's going to be a very important class because do you remember in our slides we had this round trip, the PHOTON life cycle? Basically, we are gonna work with that right now in the room manager. Okay, for the connect, I'm gonna use the console, the unit console, to output what is going on behind the scenes. So, actually, let me cut this code to be placed on under the connect method, because I want to check what is happening across the execution of those methods. When you execute the connect, I want to show on the console connecting. Then we're gonna call the PHOTON network the method connect using settings. Do you remember in the beginning of the demonstration we have copied and pasted the value of our app ID, and just out of curiosity, if you go to Window, PHOTON Unity Networking, highlight server settings, it has expanded this hierarchy, and we have this PHOTON server settings. And if you expand server cloud settings, that's the place we have the ID we have been using. And I'm showing that because let me go back to Visual Studio. When you use the connect using settings, you are basically telling PHOTON to use that previous ID. Okay, now on the start method, I'm gonna call my connect method, and we will have to perform some overrides over here. The first is gonna be, and that's important, it has to be public override void on connect to master. And let me just control dot here. Oh yeah, actually it's called onConnected to master, but there is another step, because there is no onConnected to master method, so we can override, because our class room manager is inheriting from monobehavior, which is a built-in class from Unity. And in order to have access to this method, we have to use we have to inheriting from monobehavior pun callbacks, and then we are able to keep going. Now, for this onConnected to master, we will call PHOTON network dot join lobby. That's the moment our player, we just checked he is able to connect to the master, then we are in this step redirecting our player to the lobby. Now, if everything is working just fine, then we can detect our player was able to enter the lobby by overriding the method called onJoinedLobby. For this example, we don't necessarily have to call the base method, and instead I'm gonna just check if he, just to make sure he's not in a room, then I'm gonna output on the console, Unity console, joined lobby. And we will have to set up our player. For doing that, I'm gonna create a function, a method called setupMyPlayer. It doesn't exist, so let's use this nice feature from Visual Studio. If you highlight the method and click Show Potential Fixes, you can generate the methods right away. And that's what we really want. For the setupMyPlayer method, first I'm gonna create a nickname variable, and I'm gonna retrieve this value from a specific input field we are yet to create. Input fields nickname, and we have to call the component input field the property text, which is gonna hold the value of our nickname. Then we're gonna have later on a drop down list with some options holding color names, so that our player is able to pick a specific color. But before that, let's finish this code, because we will have to consume this control. And let's consider this control as a drop down, and I'm gonna look for this control, and later on it has to be named like specifically like drop down underscore color, and we will give this name for this control later on. Get component drop down, So get components, there is no parentheses here. Yeah. So our variable ddcolor is a reference for our future dropdown. Let's pick the name by creating this variable ddcolor.options, because there is an array with holding all possible options, and the index of the value that we want is correspondent to the property value of our dropdown. If you are familiar with Windows Forms, it's a very similar approach with comparing to a combo box. Then we're gonna call the PHOTON network in order to set the nickname, and also PHOTON network local player in order to have access to the custom properties, and I'm gonna work with the color, the custom property color name. Yeah, that's pretty much it for the setup player method. Now, another override, public override void, and we want to detect when the player actually joined the room. And since when this method is called, I want to actually spawn my player. So let's create this method, spawn my player. Again, let's create this method. You just saw how to do that in a fancy way. And for doing that, let's create a player by using the PHOTON network, and there is this instantiate method. We're gonna use the player parameter, and we have to set the positioning and rotation for this player. Vector 3.0 is going to return a vector with 0, 0, 0, and there is a comma missing here. Yeah. And for the third parameter, we're gonna use a rotation with 0, 0, 0, which is returned by quaternion.identity. Do you remember I just said it's important to have our prefab? I just saved, and let's go back to Unit for a second. I'm gonna collapse this folder. It's important to have this player prefab under the resource folder, because I'm gonna go back to Visual Studio, because when you call the instantiate method from the PHOTON network class and you pass a string parameter, it's gonna look for this prefab under the resource folder. If your prefab is not here, this method is not going to work properly. So keep that in mind. And now we have to work a little bit with our player, because remember, when we first create our player, we have to make sure our camera is looking at our own player, not other players. So for doing that, let's call the component player from our player. Actually, it's not the player, it's the character movement component. And there is this attach camera method. And that method is gonna do the job. And for now, it's gonna work, but when you spawn your players, it's interesting to have a certain range in order to spread your players in a random fashion. And let's do that. Let's create this rndx variable, and let's use this random.range method from Unity. Random.range, probably it's gonna complain or not. -5 and 5. And let me just hit or control dot or mouse over, show potential fixes, because there is an ambiguity between Unity engine and system. And let's use Unity random, Unity engine dot random. Yeah. And the same thing for y, rndy unit engine dot random dot range -5 and 5. And let's place this player under this position. New vector 3 for x, rndx, for y it's gonna be 0, and for z it's gonna be rndy, but it's better to have an rndz. Yeah, let's keep things clear. And for our player, let's set the tag of our game object to hold the player value. It's just a string. Okay, now let's work. Now we have to work with the controls, the user interface. So let's go back to Unity and create those controls. First, we're gonna create a input field where our player will be able to set his own nickname. And let's go to the game object menu, UI, input field. You will see this huge input field on the scene view, but there is no problem. We can keep working by just viewing the game view, and it's going to be important to make sure about the positioning of our control. So for this input view, you will see on the bottom left corner, and we're gonna set first its name and make sure it's set to be input field underscore nickname, because our code is going to look for this specific string. And then in this middle center button, hold Alt Shift and then click. So we are going to set the positioning and the pivot for the control, and click the top center button, so your control will be aligned like that. Let's create our drop down by clicking game object UI drop down. Again, let's fix the positioning by holding Alt Shift. Click here, top center, and let's move this combo box a little bit down. So the pos y is going to be -32. Yeah. And don't forget to set the name of our drop down to be like we are expecting in our code, which is drop down underscore color. Okay, so we have our controls. Let's code our UI manager script. Let's double click this guy over here. And as always, let's fix our namespaces. The first one is going to be the unit engine, and the second one we are interested in the unit engine.ui. Yeah. Actually, we don't need the update and start methods here. So basically I'm gonna get rid of them, and I'm gonna create two methods. One specifically for handling the change of the changes over the nickname control, and another one for changes applied for the drop-down color. So let's create a public void on nickname change, and it's gonna receive a parameter, a string parameter called nickname. And let's create right now another method called, it's gonna be a public void, and it's gonna be called on color change, and it's gonna receive an int parameter called option value. Yeah. For the on nickname change, we are gonna search for actually for a game object with a tag, with a specific tag applied. For doing that, we need the find game object method. Pay attention because we have the plural and singular versions for this operation, and we are interested on the singular one, which is the find game object with tag. And we are gonna search for the string player because we need to use the component, we have to call the player class in order to have access to the update nickname method. And we are gonna pass the nickname parameter. And for changes applied on the color, first let's create a reference for our drop down like we did it previously, and I'm gonna call it like DD color. Let's search for this control, drop down underscore color, and let's get the reference for the drop down class. Yeah. Now let's get the string selected on the drop down. I'm gonna create this variable called color name ddcolor.options. Remember, this is an array of options, and we want to use the option value, because we are receiving this option value as a parameter. So now we are able to call the find game object with tag using the player tag, and finally the reference for the component player in order to have access to the update color methods. Probably it's private, so we will have to take a look on the player. Let's open the player script. I already have it opened, but if you don't, just go to Unity and double click the player. And let's check. That's the guy, the guy that is disturbing the piece on the floors, because it's not supposed to be private. Let's keep it internal. It could be public, but in our case, I'm gonna go with internal. Go back to UI manager script, and then the update color finally is visible. We can pass the color name script. Cool. That's pretty much it for this script, but we have to configure those controls in order to consume this class. Let's do that right now. Before configuring the events for those controls, the first thing I'm gonna do, I'm gonna select the input field nickname, and I'm gonna set the text property on the input field component. And for the text property, I'm gonna set my own name. And now we are good to go to configure the event. Notice here in the inspector on the bottom, we have the opportunity to work with the onValueChanged event and the onEndEdit event. The onValueChanged event is going to be fired every single time you type every single letter inside your input field. But in order to have that mindset to use the least as possible, to generate network traffic the least as possible, we're gonna use the onEndEdit event. For example, you just inserted your name on the input field and you changed the focus of your application, or you just pressed enter, then that's gonna be the event that's gonna be fired. Then let's click the plus button over here. Inside these known fields, these blank fields, I'm gonna drag and drop the control itself, input field nickname, and also I'm gonna add the UI manager component, because we need to have access to both methods that we just created. So inside no function, click here, go to UI manager, then select onNickname change, but be careful, we need this first one. Don't click the second one. The first one is the method that Unity is able to pass the value of the input field as a parameter to our method. And yeah, that's good. Let's do the same for the drop down color. But for this drop down, let's create the the reference for our component first by clicking Add Component, UI Manager. Then on the onValueChanged, click the plus button, drag and drop the control itself to the known field. Then go to No Function, UI Manager, on color change. On the dynamic int section, don't use the static parameters because we have the same thing over here, but it's not going to pass the parameter. So stick with the first one. Now we want to, instead of offering this option A, B, and C to our user, to our player, we want to present a couple of colors. So for this first one, I'm gonna set the orange, the value to be orange. Second one is going to be lime. Third, aqua. And I'm gonna include a final option by clicking this plus button, and I'm gonna set the value to be magenta. Okay. Now, let's save our scene and let's test our application. But before that, let's delete this reference for player on the hierarchy. Save the scene. Then let's play and see what happens. And there is no player. Let's see what's going on. Click the project tab and let's check our room manager script. Probably there is a missing step. Let's see the set up my player. We are setting the nickname, the custom property color name, and we are using this method on the onJoined lobby method. There is a missing point over here because we just received the signal. The player is inside the lobby, but we are not actually consuming any room. So for solving our issue, let's create a couple of parameters and let's tell Photon Network that we are interested in joining a random room actually. So first, let's create a join room parents, and it's gonna be a new up join random parents. And let's create another variable called create room parents, and let's instantiate it like enter room parents. Basically, those two variables are going to hold the filter options that we are able to pass to Photon in order to create a specific room, or to list or to find a specific room according to a certain criteria. But since we are dealing with a very simple situation, we don't want any filters to be applied in our scenario. So basically we just have to consume both variables empty like that, and then we are going to consume Photon network, dot networking client dot op join random room or create room, and we pass the options for the situation that is going to handle the joining situation and also for the creating situation, create room params. And this is a very cool method because you don't have to create a fancy algorithm in order to check if there is a specific room, and then if just in case if you don't find one and then you have to create, there is this specific function, this specific method that performs both executions all at once. And let's save and let's go back to Unity and play, and let's see if it works. So my player has been spawned and I am able to move, and notice I have my label above my player because it's parented to my player. Let's expand this game object just to check this label guy, which is this nickname label we created dynamically with our code. And let's see if we are able to change our name. Instead of my name, I'm gonna insert player and I'm gonna click somewhere else, and it's updating accordingly. And let's try to change the color as well. So it works. Now, what I'm gonna do, I'm gonna compile this application so we can test two instances of this game in order to to see this multiplayer feature working just fine. Let's do that. Go to menu File, Build Settings. Let's include our current scene by clicking Add Open Scenes. And let's go to player settings over here, because the default setting for our application is to run in a full screen window, and since we want to have two instances running side by side, I want this application to be running inside a window with instance. And let's leave the default size like that, then close the project settings window. Now, since we have the PC, Mac, and Linux standalones already selected, we are good to build our application. I'm gonna select the folder. I'm gonna stick with my folder, the folder for my project, and I'm gonna create over here a folder called PC build. Then click select folder, and Unity is going to export this game as a standalone exe file, and a couple of folders more. Let's check this folder. Then we have this photon.exe. Let's open one instance and let's move to the left. I'm gonna rename this player to be our player 1, and I'm gonna set the color to be line. Then let's open another instance. And as you can see, the fact that I just opened this instance, my Glauber player, the orange one, has been spawned on the other instance automatically. And let's change this guy, the nickname for this guy to be player 2. And as you can see, I am working in this instance, but since I changed it over here, I was able to call the remote procedure call to tell my other player, my player 1, to update my name on his screen as well. And let's change the color. Let's see if it's broadcasted accordingly. Yeah, it's working, and I am also able to move my player and jump. And let's do the opposite. Let's move the player 1 and let's check if it's refreshed on the other screen, and it works as well. It's really cool. That's pretty much it for our practice, and we have more. Let's check that. When you are ramping up a new technology, for example, multiplayer programming, probably moving cubes here and there, probably it's not the most exciting thing in the world, and I know how it feels, and because of that, I came up with this game called Intbots, and probably you have seen these robots on a couple of banners on Omnivox or in the registration form. This is the player that we are gonna see in our exercise now. Feel free to clone this repository from GitHub. There you're gonna have the opportunity to practice this exercise now. I already have my application downloaded over here. Let me just introduce you this scene, Test Arena, and let's see what we have here. So basically this robot is configured with a animation controller using animations from Mixamo, and this is a third-person game. The robot is capable of shooting lasers, and the idea is to have multiple players, up to 4 players in total, battling each other in this arena. Notice we have a script to detect if the player is going to have his view obstructed by a wall, so it zoom in and zoom out as we need. So basically that's pretty much the scene of the game. And first, let's create this application Photon, the Photon dashboard. So let's go back to our dashboard and let's create a new app. Remember to select Photon Pan again. And I'm gonna call it Intbots. And let's hit create. now we have this identifier for our application. So click on the app ID, right click and copy the identifier. Go back to Unity, select menu window, PHOTON Unity networking, highlight server settings, and under server cloud settings, paste the app ID PAN value on this text field. And now what I'm gonna do, I'm gonna select menu file, build settings, and just in case if you want to test this multiplayer feature on Unity Editor and the other instance we are gonna create, you have to select development build, and that's what I'm gonna do now. Then let's just check if the window, if the player settings is configured to run in a window, and that's it, that's correct. Make sure you have those scenes selected on the scenes in the build list and hit build. Then in the folder you have downloaded the repository from GitHub, create a folder. In my case, I'm gonna call it like PC build, and select this folder. And let's check the result of our build process. Open up two instances of our game. And I'm gonna load down the volume for this first instance. And start one match for 2 players and click find players. Do the same for the second instance and click find players. So I'm controlling the white player over here, and let's see what happens if we move closely this player to the left instance that we have opened. Notice that the movement of my player, the animation is not being synced. No, it's not in sync. And also, if I shoot projectiles, lasers, the instance on the right side is shooting for. My input is controlling the white player and the pink player as well. And also, there is another issue: the projectiles are not being replicated on the other side, on the left instance. Let's fix those issues and let's learn a couple of more components for PHOTON. Let's do that. Back to Unity, close the building settings window, and let's go to the folder. I'm gonna collapse this Photon folder, and let's go to the folder resources, expand, multiplayer prefabs, and select the player prefab. Scroll all the way down until you find the Photon transform view, and you may see we have the Photon view component, the Photon transform view component. The Photon transform view component is responsible for replicating the positioning of our players across the other instance, but that's not enough for transmitting the animation we are playing inside our own instance for the other players. For doing that, to solve the issue you just saw, we have to include another component called Photon animator view. For this Photon animator view is able to communicate parameters available inside our animation controller. For our player, let's see the animator component. We have this controller called Game Animator Controller. Let's double click, and I'm gonna move this window over here so we can have a better visibility. And those are the states for this animator controller. We can control the state for transitioning from running to jump, and then from jump to fall, and then falling to land. And all those states are controlled by those arrows. If we click each one, we can see some conditions that are applied for those transitions, for those arrows. And they are basically handled by some parameters. In that case, we have this AP, animator parameter jump. Also, for example, the animator parameter grounded, and we have specific components and codes to set those parameters, but keep in mind our animator controller is consuming these parameters, and the list of parameters can be found in the parameters tab of our animator controller, and here they are, all the parameters and a trigger for the jump as well. So if we go back to our player prefab and the Photon animator view, notice all those parameters are disabled, and also the layer, the main layer for the animation. So let's change this value, instead of disable, to be discrete. And you also have this continuous option for each one, and it means if we set to continuous, those values are going to be broadcasted into the network every single frame. And remember to be conservative with the usage of resource, because we don't need that. We just need to send this information as needed, and that's what the discrete option does. So let's live with the discrete options selected, and yeah, and that must solve our issue with the animation the synchronization of our animation. And also for the shooting issue that we just saw, we have this component called character gun. Let's open this script. And this script is responsible for shooting. And there is a method on the bottom called shoot. And basically it's just shooting as we need to respond to the input of our player inside the update function. If the player press the fire button, then basically we call the shoot method. To fix this issue, we have to call a remote procedure call in order to tell the other players, hey, please notice that I'm shooting. You have to shoot. You have to perform the shooting for my player inside your own instance. And to do that, we have actually to refactor this function. Let's do that now. I'm gonna, instead of shooting, I'm gonna copy and paste a function that I already have just to save some time. You can implement on your own. And as you can see, there is another method that I have to implement, and I'm gonna copy and paste this code over here. And basically what it does now, first when we have a call to the shoot method, this if bracket is going to check if your player is inside the room, and if this player is yours, then please execute the shot method by running the RPC, the remote procedure call. Otherwise, just execute the regular method, the execute shoot. Let's save this script. Let's go back to Unity. And let's build our application once again. Select the same folder and let's wait Unity finish this process. So it's finished. Let's open two instances again. I'm gonna select another color for this player. And let's join. As you can see, my animation is in sync in both windows. And let's test the shooting. So as you can see, the blue player is shooting in both windows. So both bugs have been corrected as we wanted. I'm gonna close those instances for now. So that's pretty much it about intbots. Please, I really recommend you downloading this example practice. Try to learn on your own, because you will have the opportunity to see in more depth the usage of PHOTON in a game up to 4 players. It's very cool. Now let's move to our second main subject for this workshop, which is exporting your game to Azure Cloud. And before that, let me just give you some context about how this technology came to this point. There was a time that when you wanted to create something more interactive or a game for the web, the best option you had was Adobe Flash. And basically, when Steve Jobs came up with iPhone, this complete game changing product, they basically said Adobe Flash was not going to be supported on iOS, and it actually killed Adobe Flash because as the years went by, basically the users were using less and less the PC, and they started using more mobile devices. And that's one of the reasons Adobe Flash is not going to be supported anymore. Coincidentally, this month of December. And we really needed an option to replace Adobe Flash, and that's when HTML5 came in. This technology is able, HTML5 nowadays is able to handle 3D graphics and also, believe it or not, binary codes inside your browser. For the presentation layer, in order to handle 3D graphics, we have this technology inside the HTML5 called WebGL. And for handling binary code inside the browser, there is this very interesting technology called WebAssembly. And by the way, in my personal opinion, this is one of the most exciting features that we have the opportunity to work with nowadays on the web. Just out of curiosity, the company behind AutoCAD, a company called Autodesk, they were able to migrate a code base of 30 years for AutoCAD in order to compile this project to run on the web using this technology called WebAssembly. And this is very interesting because instead of using JavaScript, your binary code has the possibility to run way more faster than comparing to JavaScript. And this is very important when you are dealing with 3D graphics. It's very important to have this performance in order to minimize the gaps for your player. And specifically for Unity, when you when you plan to export your game for the web, there is an option so we can export this game. It's called WebGL platform inside Unity. We are gonna see that in a minute. And the project is compiled in order to use WebAssembly as well. And since we have this web output, we are able to publish this game inside a cloud provider, and that's what we're gonna do using Azure Cloud. But to make our lives easier, we are gonna also create a ASP.NET application in order to serve as a container for this HTML5 output generated by Unity. And let's do that in this example. The first thing we're gonna do, we're gonna create a ASP.NET application. Let's go to Visual Studio 2019. And let's click this create new project by clicking this button and select the project type ASP.NET Web Application.NET Framework and then click next. I'm gonna call this project WebGL app and I'm gonna select the folder, the same folder we have been using for intbots level up. And I'm gonna create the folder over here. I'm gonna select this folder. Then click create. Make sure you have selected the empty option and then click create. Now we need to perform some modifications on the webconfig file in order to support the unit output. Because if we do not tell our ASP.NET application that we are gonna handle unit files, it's not going to work. So the easiest way you can check how to modify your web config file is by going to Google and search for WebGL server configuration code samples, because it's going to return on the documentation for Unity an example for the ASP.NET web config file, the code that you are supposed to place there. First, you're gonna see here, but before that, make sure you have the right version selected for the example. In my case, I'm using the 2020.1. And the first example you have here is a configuration, is a code specific for serving compressed outputs for Unity. That's not our case in this example, because we are interested on the uncompressed WebGL build, which is by default when you generate WebGL outputs. And I'm gonna copy the entire code. And I'm gonna get rid of everything, and I'm gonna paste the codes over here. Let's save. And now we are good to go back to Unity, and I'm gonna go back to our intbots application. And first let's go to File, Build Settings, and let's switch the platform by clicking WebGL and then click the button Switch Platform. It's gonna take a little while. And that's it. Now, let's click Build. Inside the folder for our project, I'm gonna create a folder. Actually, I'm not going to create a folder. I'm gonna select the folder of our ASP.NET application, which is the WebGL app. And then I'm gonna hit select folder. Now, this step is going to take a couple of minutes. Sometimes for me it takes up to 5 minutes for this project. So let's leave Unity working in the background, and we're gonna go back later on. In the meantime, I just wanted to present some use cases and what is the advantage of exporting your game for the web. The first thing I'm gonna show you is an application that I came up with last year, which is an example of integrating a Windows application, Windows Forms application with Unity by using a control from Windows Forms called WebView. If you search on the toolbox, there is this web browser control where you can place somewhere in your form, and then there is this property called source, and you can set to a link. Let me copy and paste on my browser this URL so you can have an idea about what we're gonna get there. So it's basically an application I have created using Unity, and here we don't have anything on the screen, but keep in mind that this is a Unity application. I'm gonna close for now, and let's run this Windows Forms application. The idea of this application is to simulate a bike factory. We have the opportunity to register and manage bikes. I'm gonna load some bikes into this grid, and as I keep selecting some bikes from my list, you will see those 3D bikes represented on my internal browser. And I can, for example, accelerate my bike. I can change the angle of my camera. And this is very interesting because it is possible to perform a communication from the Windows Forms, sending commands inside to my web browser, and vice versa as well. You can check that I have posted these codes over here. Feel free to take a look. It is very interesting, this use case of integrating Windows Forms with Unity. Feel free to clone this repo. Another use case for using WebGL is to create your own portfolio of games. Say you are looking for a job to get into the gaming industry. I'm not sure if you are familiar with the section of Omnivox, but here you have this portfolio section, and you can, for example, you can create your portfolio of projects. And just to illustrate, I came up with these two games that I have done on in a couple of years ago, and I created my own portfolio inside LCI Education Network portal. And let's open this project over here. And I think this is a very good idea because say you are sending your CV to a recruiter and you are basically explaining that you have done some games on the college when you were studying at La Salle College, for example, but the recruiter doesn't have anything to check if your game is really good or very interesting. And that's where a portfolio can be a good fit in this situation. You can, here in the LCI portal, you can post pictures, videos about your game. But here I also have included a link in order to, if someone just wants to try out my game, it's possible to open up the link, and the game is gonna run on the browser out of the box. For this specific game, I have posted on Azure Cloud, and that's what we're gonna do in a couple of minutes with intbots. And let's just wait this progress bar to be finished. So Unity just finished the output, the web output. And the cool thing is you can even run full screen the game. Yeah, really cool. And that's the idea. I really recommend you creating your portfolio of projects you have done at college, and it can really help you on your pursuit for a job. So let's go back to our demonstration about how to export our Intbots game to Azure Cloud. Since Unity just finished processing our WebGL output, let's go to the WebGL app folder. And this output basically consists on this index.html file, the template data folder, and finally the build folder as well. Inside the build folder, we have those files which consists our WebGL 3D graphics and also the WebAssembly binary code. Let's go back to Visual Studio, the ASP.NET project. And now what I'm gonna do, I'm gonna include those output items inside this solution since they are on the same folder. For doing that, I'm gonna click the Show All Files button, and I'm gonna keep pressed Ctrl on my keyboard, and I'm gonna select index.html file, the template data, and the build folder. Then I'm gonna right click and hit include in project. Then I'm gonna click again show all files, and that's pretty much it. Now let's see if we are able to run locally on our own machine this WebGL output by using an internal web server offered by Visual Studio called IIS Web Server Express. Right click the index file and then click View in Browser. If you receive this warning, that's okay. And that's good. Intbots is running inside our browser, and we have also the ability to run in a full screen mode if we want, or just press ask to go back. That's very cool, but it's running locally. We really need somewhere to host our web application. And that's what we're gonna do now by publishing to Azure Cloud. Right click your project, your ASP.NET project, and then click Publish. Select Azure, then click Next. By default, it is selected with Azure App Service. That's what we want. Click Next. Since this is not the first time I am creating an application using my account, probably you will have to log in using your own, and probably you have to create an app service instance by clicking the plus button. And make sure that you select on the hosting plan field an option with this F1 value because this F1 means you are going to use the free tier. You are not going to spend a single dime by using this service. I'm gonna select my app service instance, and I'm gonna actually click plus, and I'm gonna provide the name int bots tree create. Once it finishes, it's going to show you the app service instance. Then you just click finish. Then it's going to show you the public URL your application is going to have. But before testing this out, you have to actually publish your application by clicking this publish button. Let's do that. It's gonna take a little while. Once it completes the process, it's gonna open your public URL with your game, and let's see if it works. that's it. It works. Cool. Now you are able to publish your own games and create your portfolio on the web. I look forward to check what you're gonna do in the future. Don't forget to share with our innovator in technologies so we can check this out as well. Last but not least, I would like to show you how you can manage those applications that you are submitting to the Azure cloud. The link for that is portal.azure.com. You sign in with your Azure account, and then you go to App Services. Here you have the opportunity to manage them, or for example, if you want to delete a specific application, you just select on the checkbox, and then you can click on the delete button if you, for example, if you just created by mistake. Since we are approaching the end of our workshop, I just wanted to share with you the links for all the source codes you have seen during the presentation. Please feel free to clone those repositories. And I would like to thank you for attending. Thank you very much. I really appreciated for this having this opportunity. For me, it was such a great pleasure. And I give the floor back to Philip. Thank you, Philip.
First of all, I would like to thank you for the amazing workshop. It is indeed a very good subject. And what I see on my research is that this multiplayer subject is becoming like really important on the industry. So I think it really adds, at least for me, as an important subject. So thank you for this knowledge. And I would like to thank you everyone to join this workshop. We look forward to host other workshops in the future with other game-related subjects and for sure another subjects as well, like programming and stuff. And if anyone wants to join it, feel free. We need people with good mind, with who are really willing to help and to make this kind of events to everyone, to all the students in the college, and to everyone willing to learn. That's it.